Alright, we have lesson 7 where we're going to talk a little bit more about classification of solutions. We've already mentioned a couple of instances where we either have no solution to a problem or one solution. So let's take a look and see what patterns we can find when we know that linear equation either has a solution or no solution or maybe infinite solutions. So go ahead and do exercises 1 through 3 on your worksheet right now. Remember that the solutions presented once you continue the video are one of many of the examples of the process. The important part is getting the correct value for x. So go ahead and do exercises 1 through 3 and then continue the video. Alright, so here again is some sample work, but for problem 1 you should have come up with one answer, x equals 4. For problem 2 you would have come up with two values that don't equal each other. So in this case, -3 is not equal to 5. So this equation has no solution. And the third one, you could have ended up with either 7x equals 7x or maybe -3 equals -3. Alright, so let's go ahead and copy these equations in your journal so you can refer to them throughout the discussion. Alright, when you've done that, was there anything new or unexpected about exercise 1? So, did you figure you were going to come up with one solution or not? No, we solved the equation for x and x equals 4, so that's what you would generally expect to happen. So what can you say about the coefficients of terms within the equation? Remember, the coefficients are the values that precede a symbol. As far as this is a coefficient also, any value that has no symbol after it is considered a constant. So right now we're looking at what do you notice about the coefficients in 7x and 5x? Well, you would say that they are different. So do you think any number other than 4 would make this equation true? Well, you probably don't think so, but you'd have to try different numbers in order to find out. So the old guess and check. So instead of having to check every single number to see if it makes the equation true, we can look at a general form of an equation to show that there can only be one solution. So given a linear equation that has been simplified on both sides to a times x plus b equals c times x plus d, where a, b, c, and d are constants and a is not equal to c. So in this case, a and c are not the same, and b and d are not the same also. They're all different numbers. So we can use our normal properties of equality to solve for x. And even though this looks like a long drawn-out process, it really does solve for x. It's just we can't simplify. That's why at the end we end up with kind of this mess. But if you follow through, you can see where we're using the properties of equality to transform the equation so that we can solve for x. So here we have subtracted b from both sides. Then we have subtracted a cx, c times x, from both sides. By using a distributive property, we can factor out x and have a minus c. So now, if we have a minus c, divide that by a minus c, we would essentially have d minus b over a minus c. So that's where we end up with x is equal to d minus b divided by a minus c. So the only value of x that will make the equation true is the division of the difference of the constants by the difference of the coefficients of x. In other words, if the coefficients of x are different on each side of the equal sign, then the equation will have only one solution. As an aside, if the coefficients of x are different and the value of the constants are the same, the only solution is x equals 0. Consider the following equation. So here we have our coefficients in front of x are different, but our constants are the same. As you followed through the process using the properties of equality, notice what happens. X is equal to 0. So the only value that will make 2 times x plus 12 equals x plus 12 is true is 0. So is there anything new or unexpected about exercise 2? Well, no, we tried to solve the equation and got an untrue statement, which is -3 is not equal to 5. Therefore, the equation has no solutions. So what can you say about the coefficients of the terms with the second equation? Well, the coefficients are the same. And what can you say about the constants of the second equation? Well, the constants were different. So it is time to begin formalizing what we have observed as we have solved equations. To begin with, we have learned that some linear equations have no solutions. That is, when we solve an equation using our properties of equality and end up with a statement like A equals B, where A and B are different numbers, we say that the equation has no solution. To produce and/or recognize an equation with no solutions, consider the equation with both sides simplified. The coefficients of the variable x will be the same on both sides of the equal sign, and the value of the constants on each side will be different. This type of equation has no solution because there is no value of x in an equation such as x plus a equals x plus b that will make the equation true. So compare the equation x plus a equals x plus b with exercise 2. What do you notice, or what similarities do you notice between the two of them? All right, let's talk about exercise 3. Was there anything new or unexpected about exercise 3? Well, you might have said yes, because when solving the equation you can either get -3 equals -3, which did not give us a value for x, or you could have had 7x equals 7x, and we're not sure what to do next or what it means. So let's start with the first one. Is -3 equals -3 a true statement? Is it always true? Well, yes, it is always true. So if 7x, or 7 times x equals 7 times x, will we always have an equality no matter what number we choose for x? You should say yes, because it is identity, because the same expression is on both sides of the equal sign. So what can you say about the coefficients of the terms within the equation in exercise 3? Well, the coefficients are the same. And what can you say about the constants in the equation? Well, the constants are the same also. So we now know that there are equations that produce statements that are always true. That is, -3 will always be -3, 0 will always be equal to 0, and 7 times x will always equal 7 times x no matter what the number x happens to be, because 7 times a number is just another number. So when we solve an equation using our properties of equality and end up with a statement like a equals a, where a is a number, then we say that the equation has infinitely many solutions. So to produce and or recognize an equation with infinitely many solutions, the coefficients of the variable x and the value of the constants will be the same in the simplified expressions on both sides of the equal sign. This type of equation has infinitely many solutions because any value of x in an equation like x plus a equals x plus a will make the equation true. So compare the equation x plus a equals x plus a with exercise 3. All right. Work to solve these equations. What do you notice about each of them? That is, what can you see in an equation that will tell us about the solution of the equation? See if you can apply the general equations that we came up with and see if you can spot any similarities between those equations and what is grouped in column 1, column 2, and column 3. Right, so for an equation 1, where both sides are simplified, the coefficients of x and the constants in the equation are unique. For example, it is a times x plus b equals c times x plus d. Notice that every value, constant or coefficient, is different in every one of these equations. So therefore, there's going to be a unique solution, x equals d minus b divided by a minus c, as in the first column. So try that without even using your properties of equality. Can you do d minus b divided by a minus c and see if you can get a value for x? Okay, for the second column, if it's in the form of x plus b equals x plus c, then there will be no solutions. Notice how the coefficients are the same. Coefficients are the same here, and the coefficients are the same here, which means that the answer to our question is going to be that there is no solution. And then for the last one, when an equation is in the form of x plus a equals x plus a, then there will be infinitely many solutions, as in the third column. Notice that the coefficients are the same and also the constants are the same. So these types of equations here are going to have infinite solutions. All right, it's your turn to do exercises 4 through 10. To get you started, when you have an equation like this, these are the types of answers that are expected. So please read through it and then continue on with 5 through 10, answering in the same manner. When you are done, go ahead and continue the video. All right. So, forgot to tell you, be expected to share your equations for 8 through 10 in class. So here are the answers for 5, 6, 7, and then again for 8, 9, and 10. Here's some hints of what you should have. But obviously you're going to have a different equation than someone else at your table group, so you will be sharing those problems in your presentation. All right, let's wrap this up. So we know that equations will have either a unique solution, no solution, or infinitely many solutions. We know that equations with no solution will, after being simplified on both sides, have coefficients of x that are the same on both sides of the equal sign and constants that are different. We know that equations with infinitely many solutions will, after being simplified on both sides, have coefficients of x and constants that are the same on both sides of the equal sign. All right, we'll see you in class.